So welcome to 1.5 divisibility by 3 or 9. So you're seeing the 3 times table in front of you. That shouldn't be too hard to do, right? So please do this on your own. Okay, so there's the 3 times table. Now yesterday we focused on some tricks to tell if a number is divisible by 2 or 5 or 10 or 25, right? And today we're going to focus on the 3 times table and later the 9 times table. And there's a trick for that too, but it's not at the end, right? You can't look at the end of these numbers and tell if they're divisible by 3. Can't. So does anyone know the trick? There is a trick. And this is totally a trick, but it turns out to be true. So let's see how the 3 times table starts. It starts at 3, then 6, then 9, and 12. All right, but let's do 1 plus 2. And that's not a thing, right? We don't usually add the tens place and the ones place, right? But let's do 1 plus 2. Well, that's interesting. I get 3 again. And let's add 1 plus 5, and, well, I get 6 again. And this is 1 plus 8. We get 9 again. That's interesting. Do the rest of those. This is called summing the digits. And you never ever do this other than for this trick. Well, 21, or 2 plus 1, back to 3. 2 plus 4, back to 6. 2 plus 7, back to 9. 3. Now it restarts again. 3 plus 0 is 3. 3 plus 3 is 6. 3 plus 6 is 9. And then look what happens when we get to 13 times 3. We go up to 12, all right? And then 14 times 3, let's just do that. 3 times 4 is 12. You get 3 and 1 is 42. And 42, you get back to 6 again. And it starts going up to 15 and 18 and things like that. But it turns out if you sum the digits of any number on a 3 times table, it adds up to a number on the 3 times table, and usually the ones at the bottom of the 3 times table. And this is always true. And it's also true in reverse. If the digits add up to a number that's on the 3 times table, you can divide it nicely by 3. It's called the sum of the digits trick. All right, so take these notes and let's see it in person. So 51, right? We could divide 51 by 3 the long way, and since we're starting, I'm going to do that. 3 into 5 goes 2. 2 times, 3 into 5 doesn't go 2, Mr. Ben. 3 goes into 5 once. Remainder 2, bring down the 1. 3 into 21, 7. So it turns out 51 divided by 3 is 17. So it goes in evenly. It's divisible. But we didn't need to do all that work to tell that was going to happen because 5 plus 1 is 6. So this is a yes. All right, let's look at 331. It's got 2 3's in it. Is it divisible by 3? Well, 3 plus 3 is 6, plus 1 is 7. 7 is not a number on the 3 times table, so it's no. And if we try to do that division, let's just show you what happens here. 3 goes into 3 once, right? Bring down a 3. 3 goes into 3 once. Everything seems great. But then we get this 1 remainder, and we get 11, 1 remainder, also known as 11 and 1. Is that right? 11? No, I've done something wrong. Oops. Right. Oh, yeah, you have to put a 0 here. My fault. You have to put it in the 0. Oh, my goodness, horrible. So it has to go 110, and then it's remainder 1. Okay. So either way, it's not divisible. All right, so 504, is that divisible by 3? Well, 5 plus 0 plus 4 is 9, so it must be divisible by 3. And let's just do that because this is going to be a thing. 3 goes into 5 once, right? I'm doing horrible here. Remainder 2, bring down a 0. 3 into 20 goes 3 times 6 is 18. Remainder 2, bring down a 4. 3 into 24, yeah. 504 divided by 3 equals 168. It comes out nicely because we can tell that ahead of time by the sum of the digits trick. Turns out the 9 times table has very similar trick. So let's do the 9 times table. So 13 times 9 is 27. It's 117. All right, so let's see what happens when we sum the digits up. Well, not 1 plus 8, 9. 2 plus 7, 9. 3 plus 6, 9. 4 plus 5. It's even, you gotta be kidding. Every single number on the 9 times table adds up to 9? Wow. In fact, that's just incredible. Now, finally you get to this one and it's up to 18, but then you get back to 9 again, right? And then 9 times 14, and it will sometimes add up to 27 as you get bigger and other numbers on the 9 times table. Some of you learned from your teacher in elementary school a trick for a 9 times table. You can use your fingers to figure out what the 9 times table is. If you've never learned that trick, then you don't know what I'm talking about. But the reason the finger trick works is because you have 10 fingers, and the trick uses up one of the fingers, and so you have 9 fingers left. And so the 9 times table always adds up to 9 until you get to 99, and then it adds up to 18. So let's use that trick. Are these numbers divisible by 9? Well, 3 plus 3 plus 3, that's 9. So this must be divisible by 9. Now you don't have to check it, but I'm going to. 3 times 9 is 27. And remainder 6, bring down to 3, 9 into 63, 7 times. Yeah, it goes in exactly 37 times. Oh, so I should write yes. Oh, I forgot to write the instructions here. So let me put that in there. Is the number divisible by 9? 334, 3 plus 3 is 6 plus 4 is 10. That's a no. You'll get a remainder. 288. 2 plus 8 is 10 plus 8 is 18. Yes, so if it adds up to 9, 18, 27, any number on the 9 times table, it's really the same exact trick as the 3 times table. It's just that the beginning of it is so much easier and nicer, but this is yes. All right, so you're going to do just like yesterday we did for 2, 5, 10, and 25, you're going to do 3 and 9. So 144, right, adds up to 9. So 9 is on the 3 times table, and it's on the 9 times table. So this one has both. Both 3 and 9 go in there. 1 plus 0 plus 2 is 3. So 3 goes in there, right, but 9 does not, right? 3 is not on the 9 times table. And let's just make sure we're clear about that, because I should have done one like this. So, right, 102 divided by 3, and 102 divided by 9. 3 goes into 10 3 times, remainder 1, 3 into 12, 4. 9 goes into 102 once, remainder 1. 9 goes into 12 once, but now we have a remainder. We have a remainder of 3. So 9 does not go in there. 2 plus 2 plus 2 is 6. Well, 6 is on the 3 times table, but 6 is not on the 9 times table. It's too small. So only 3 goes in. And 1 plus 7 is 8 plus 0 plus 1 is 9. So again, 9 is on both of them, and so that gets both 3 and 9. Whenever you have a 9 there, you'll also have 3. It's just like when we ever had 10 on our list yesterday, or in the last lesson, we always have 5. Whenever you have 10, you have 5. You could have 5 without 10, though, but not 10 without 5. And you can have 3 without 9, but you can't have 9 without 3. Okay? All right, so now we're going to combine the 2 days, and this is what you'll do on the test when we get to this. You're going to check all these different numbers. So I showed you a trick yesterday. Please do this. All right, so I'm going to look for all the even numbers. 96 is even, 100 is even. All right, now I'm going to use my sum of the digits trick for 3. All right, so 3 is there. If you want to write 9, right, because 4 plus 5 is 9. 7 plus 5 is 12, so 3 is there. 9 plus 6 is 15. 3 is there. 1 plus 0 is 1, so no, 3 is not there. 2 plus 2 plus 5 is 9. So 3 and 9 are there. So now I'm going to check the ones that ends in 0 or in 5. Well, 45 does, so I'm going to put the 5 there. I'll put a little comma there. 75 is good. 96, no. 100, and if it ends in a 0, you've got the 5 there. And 225 ends in 5, so I have the 5 there. And I should put a comma here. And, if you don't like the way I've spaced this out, that's fine. You can do it your own way. So now I'm going to check 10. Well, I'm only looking for numbers that end in 0, so that's this one, 100. And then we've got 25. 25 needs that right. 25, 50, 75 are double 0. Ooh, 75 is divisible by 25. I'll be consistent the way I did this and leave a space there. I'm not going to do that. That's sloppy. So that one's done and that one's done. And 96 is done. It's 2 and 3. 100 also has 25. I'm going to neaten this up though and put 2 this way. So 100 has those. And 225 sure ends in a 25. All right, so this one has that. All right, what number is that? Well, that's 1,026,000. And you don't say and 6. I said that wrong. It's 1,020,000. I forgot the thousand. 1,020,006. Now the question is it divisible by all these numbers? Well, it's even, so it's got 2. Now let's do the sum of the digits. 1 plus 2 is 3, plus 6 is 9. So yeah, 3 is there, and 9 is going to be there. 5 is not going to be there. It doesn't end in a 0 or 5. 10 is not going to be there, and 25 is not going to be there. It's just 2, 3, and 9.